Yes, good evening all. Now this will be mostly this will be the last lecture for DCS, that is digital control system. We had seen what is Z transform, right? What are the properties? What is the Z transform of what is standard signals, right? All those things we had seen. Now the last thing is how to judge stability for the system in whenever will be for the digital system when we are using Z transform. I'll not go into so much details because that is not in your syllabus definitely. So whatever are the main points I'll try to cover. Will not go into details of that, but before that, one more thing. I promised you that yes, I'll tell you what is convolution, because we had seen one property for convolution, that convolution is getting converted into just simple multiplication when you are talking about Z transform. So what is convolution? Just a conceptual thing. It's not just simple multiplication, right? So what do you mean by convolution? I'll just take one example and I'll explain. Okay. So today's first point will be convolution summation. Okay. Now convolution summation means, see, like you are having a system, right? We had seen when we trying to learn the Laplace transform that the transfer function of the system is the unit impulse response, you know. So the same concept definitely will be applied over here also, right? Unit impulse response, whatever it is, that gives you the transfer function of the system. So if I'm saying this is x n, correct? Now the instances we are naming by n or k, whatever is, both the things are same, yn, correct? And let us say the transfer function, the unit impulse response for this particular thing is, we got to be hn. So I'll write impulse response. Okay. Now just a minute. If I want to talk about the input, let us say the input is having n number of samples. So at t equal to 0, x0, x1, x2, x3, and will continue till infinity definitely. Okay, will get applied on the system and you are going to get y of n. So how we can write this y of n as y of n is equal to x0 hn, correct, plus x1 h n minus 1. Why? Because we are going ahead nth instant, so definitely when you are moving on the right hand side, right, this is your sequence, right? We had seen this shifting on left and right. Again I'm repeating, if you are shifting on this side, right, that means if this is the nth instance, then this is going to be n minus 1 time lag hai. So lag you will definitely will represent by minus, and on this side it is leading, you are going for the previous instance, so this is going to be n plus 1. And we had seen this thing shift towards left and right. Yeah, so n minus 1, I'll say x2 h n minus 2, and will continue, correct? So whatever is this thing is called as actually convolution summation. How I can write this? I can write this thing as k equal to 0, infinity. So this k we are using for number of instances now, and this n is representing that nth input that you are having. Okay, so xk and hn minus k, and this summation is called as convolution sum. Now we'll take one or two values and we'll try to see this convolution sum, is it just a multiplication or something else, right? So I'm just taking example. I'll change the ink color. Let us say xn that you are having is 1, -1 and 2. Okay, and let hn, that is the impulse response for this system, particularly let us say it is 2, 1 and -1. Okay, right? So you know that yes, y of n is going to be summation of k equal to 0 to infinity x of k, correct, h n of k. Okay, so just a minute. Yeah, so see xk. So if I'm talking about the first value of k, that is k equal to 0, so it is going to be x0, right? And or I'll write y0 first. Wait, I'm talking about n is equal to 1, so it will be y of 0. N is equal to 0, so y of 0 is going to give me x, k ka value also 0, and h, n is 0 and k is also 0. Even if you increase value of k, negative thing is not possible, right? Not existing. So 0 minus 1, that is not existing, so will not go ahead. Then plus. Now otherwise I'll say I'll just calculate this thing, y of 1. Now when that means n ka value is 1. So I'll write this first. X of 0 means 1, and h of 0 is 2. So the value that you are going to get is 2. Okay. Now when I'm saying y of 1, x of 0, because k ka value is starting at 0, h, n value is 1, minus k is 0, so 1 minus 0, correct, plus. Now you increased value of k. Now your n is 1 only, so it is going to be x of 1, correct, and h will be n ka value 1, k ka value is also 1, so it will become this, right? After that it will start becoming negative, not possible. So what I can say, x0 h1 plus x1 h0. So x0 and h1, that means 1 plus minus 1 plus 2 into 2. So it is going to be 1 minus 2, that is minus 1. Okay, now if you are talking about y is equal to 2, that means n ka value 2. So what is happening is, it is like your C ka loop, right? Loop inside the loop. Your outer variable is n, your inner variable is x, right? You are changing, sorry, not x, your k you are changing internally, going till the last value. Again you are increasing value of n, right? One more thing I'll tell you and then I'll stop. So this is convolution, not this is just a simple multiplication. But as soon as you take Z transform, this convolution gets converted into xz hz, right? And the work becomes very simple, and that's why this is the one of the advantage of Z transform. If you can remember, one of the property I told you, convolution summation gets converted into simple multiplication. Okay, so what I can say, x0, we are starting with x0. Now h2 minus 0, so 2. Okay, then plus you have increased value of k, that is k is 1. So h will be 2 minus 1, that is 1, plus x2. Now k is 2, so your h will become equal to 0. 2 minus 2, that is 0. Yeah, so x0 h2, x0 h2 minus 1, x1 and h1, so again minus 1, x2 and h0, that means plus 4. That means you got value to be equal to 2, right? So if I'll write y of n in this case, so we are getting sequence of sequences, right? Different instances, instantaneous values, 2, minus 1, 2, and definitely this is going to continue. Why I have told you this thing? You should know what is convolution. Whether it will be asked in the paper or not, that is a different thing. Yeah. Okay. Now we'll go for the stability of the system. So second point. And to know the stability of the system for the digital systems, right, 2-3 points are very important. First thing is the mapping of a system, mapping of S-plane to Z-plane. Okay. So one relation we are aware of, right, that is Z is equal to e raised to st. Now this t is a constant, right, and normally it is considered to be equal to 1. So that's why you will find the main relation, even if it is constant, it is not going to matter. So the main relation is e raised to s. Correct? Now e raised to s, I'll be able to write it as e raised to sigma plus j omega. So if I'll separate it, it is going to be e raised to sigma into e raised to j omega. So definitely if this value e raised to sigma, if I'm saying r, right, then it will be e raised to j omega. So I'll be able to write r, e raised to j omega means what? Angle is omega. So it's very much clear that your angle is going to change and your r is also going to change as per that. So this is representing a circle. Correct? How it is going to be the circle, what will the radius, and all these things we'll study, right? But meanwhile, if you are talking about magnitude of this z, it is going to be r. Correct? And if you are talking about angle of this z, then it is omega. And these are the main what we can say, mapping parameters, right? So let us see I'll write it over here. If I'm talking about S-plane and Z-plane, okay, 3 main things are there. If your S is minus infinity, that means extreme left, I'll write. But we are talking about vertical lines. I'll write it neatly. Just a minute. It should not confuse you. extreme left. Correct? अरे I have written it extreme left. Sorry, vertical line लिखना था ना. Vertical lines. Okay. So s is equal to minus infinity. S, that means e raised to minus infinity, it is going to be equal to 0. That means this is 0. Z is 0. I'll write Z is equal to 0. Now Z is equal to 0 means its magnitude is also 0 and angle is also 0. So magnitude is 0, angle is also 0. That means it is origin. Right? Okay. Then the second point is when s is equal to 0. That means I can say it is a imaginary axis. Correct? So this imaginary axis now, s is equal to 0. That means e raised to 0. E raised to 0 is 1. That means z is 1. So when z is equal to 1, that means it is a circle with unit radius. Your omega is changing, right, from 0 to 360. Okay, magnitude is of 1. Okay, so magnitude is 1 and angle is 0 to 360. That means it is a circle with unit radius. I'll write it. Why I am saying angle 0 to 360? Because see, when you are saying s is equal to 0, that means on the plane this line, right, s is equal to 0, frequency is changing from 0 till infinity and till minus infinity. On the same line, right, the magnitude over here is fixed, that is 0 for this s. So z ka magnitude is also fixed. So magnitude is fixed, so it has to be a circle. Right, but the angle is changing, omega is increasing, correct, on this side also and on this side also, and that's why it is going to be a circle with unit radius. Okay, then the third thing is s is equal to infinity. That means extreme left, extreme right. Now in this case, what is going to happen? E raised to infinity. That means z is equal to infinite. So it will be a circle with infinite radius. I think this much thing is clear. Let me draw it in tabular form. Okay. Yeah. Okay. So how these vertical lines are getting represented in Z plane, that we had seen that vertical lines are getting converted into circles. So definitely I can write on this side as circle. Now what is happening to the horizontal lines? We want to see that. But before that, I'll draw one diagram and I'll try to explain whatever we try to see over here on the graph, right? Okay, let me save this. Yeah, see now. If I'm talking about S plane. Right. And let us say 3 lines I'm drawing. 1. I'll not draw arrow because it may again confuse, and I'll use different color. So I'm talking about this line. then let's say this line, red one, and third one is this. Okay, and I'll name them. This is A, B, and C. Okay, this is S plane, so this is sigma, and this is J omega, and this is S plane. And now we want to see what is going to happen to the Z plane. See, now when this is the thing, we had seen that S is equal to 0, right? S is equal to 0 means Z raised to 0, that is 1. So you are going to have a circle, unit circle. So I'll try to draw a circle. Okay, and I'll select it, try to adjust. So this thing is representing your curve B, or your horizontal line, that is B. I'll write it B, correct? And this one is having, or I'll write, this one is S raised to 0, that is equal to 1, which is your, Z raised to, Z is equal to E raised to S, and S is 0, and that's why it is equal to 1. So this is having radius to be unit, so I'll draw it, yeah, and I'm saying it's 1. Okay. Now when it is extreme left on this side, that is minus infinity, it is becoming origin over here, correct? एक काम करना था बेटा, instead of this I'll draw a circle with red color, because this red will map this red color properly. Yeah, let me see now whether it is getting fitted perfectly over there. I think it's okay. Okay, yeah, then I'll go for, I was talking about this thing now. Now when it is extreme left, that means minus infinity, e raised to minus infinity is going to be 0, and that's why I have drawn it over here as 0. But it is not at infinity, it is at some value, but on the left hand side. So definitely the circle will have less radius because it's reducing. As you are going on this side, S ka value is become negative and negative, you will find it will, the radius will keep on reducing. That means if I'll try to draw the circle, then this circle is representing actually A. I write it over here, A. Okay, right? When you are going on this side, extreme right, e raised to infinity will be a radius with infinite, a circle with an infinite resistance. But now it's not infinity, but it is on the positive side. So definitely the radius is increasing, and the circle with higher radius, yeah, I think this is okay. Okay, and this circle is representing the curve C, or the line, vertical line C. Okay, now if we are having a horizontal line, see, now what is happening? Frequency is increasing and decreasing, right? We had seen Z is represented as R at an angle of omega. So here omega is going from 0 to infinity, 0 to minus infinity, and this is in terms of angle. That means at this point, right, some value of whatever will be your let us say you're at this point for this particular circle, correct? You are at this point. So as your frequency is increasing, right, it is going like this, it is going to move like this, going till infinity. When you are going down, it is moving like this. And that's why, because omega is representing the angle, and angle definitely has to be shown in the form of the circle, and that's why it is a circle, it is circular thing. Now see, if I'll draw a horizontal line, let us say I'll name it D and F, and I'll draw horizontal line. This one, D, and one more I'll draw. Okay, this one. See now, this line I'll name it as D, and this line I'll name it as F. Okay. Now see, you just see for D, or first we'll talk about F. Now what is happening? The angle is remaining same, but definitely the radius is continuously changing. And from this to this to this, if I'll go, radius is increasing, correct? That means an angle should be constant. Meaning of that is, yes, it should be a line from the origin with increase in the radius, but angle should be same. So for all these points, angle is going to be the same, right? And this angle of Z is going to be omega, correct? And this thing is representing F. Okay. Now why I have drawn it in first quadrant? Because your omega is positive. Here your omega is positive. Here your omega is going to be negative. So if the omega is negative, definitely I have to draw that line in the fourth quadrant. Alright. So this is representing what name we had given, D. Okay, yeah. So I tried to explain. Now before I'll go ahead, actually I want to show you one video representing this. But if I'll go for the video, I think this thing will go, whatever I had drawn. So let it be video. I'll show you in the last, right, related to the stability, related to the mapping. So we try to cover one thing, that is mapping, for which is required for stability. Okay. Now I'm talking about B point, that is definition of stability. Because we learned all these things in S domain, it's very easy to understand. Definition of stability. Okay. So there are two definitions of stability, and try to explain the same thing in different manner, nothing else. Alright. So first one is asymptotic stability. I think Lloyd sir taught you. So asymptotic stability means it depends upon the initial conditions. A system is asymptotically stable if its response for any initial conditions decays to zero. Whatever might be the initial condition, right? For those things, if your system is giving decaying response, then the system is called to be stable. So I'll write, if its response to any initial conditions decays to zero, That means limit k tending to infinity, y of k ultimately should become equal to 0. As the number of instances increases, right, the output of the system should decay, right? Now if the response due to the initial conditions is bounded, it is not going to 0. So I'll write if response due to initial conditions remains bounded, right, but not decaying to 0, to 0, then we say the system is marginally stable. Okay, so this is one way to talk about the stability of the system. Then the another one is BIBO, bounded input, bounded output stability. Okay, let me, yeah, yes. So I'm talking about the second condition now. That is bounded input, bounded output stability. Yeah. Now, bounded input, bounded output stability means when the input that is given is bounded, right? Output should be also bounded one. A system is said to be BIBO stable if its response to any bounded input remains bounded, right? So very much clear from the statement, from the name only. When the input is bounded, output of the system should be bounded one, right? That thing should be getting should get satisfied by the system. See now, like just now I had drawn for that. To explain you the convolution, right? This is x of n, it was, and this is y of n, correct? X of n, y of n, and h of n, correct? And if this is bounded, bounded means within some range, it is not getting value of input is not getting exceeded above a particular limit, that means it's bounded. I think I have explained you this thing for in the S domain also, how to talk about the system stability, right, in these terms. So bounded input should give you bounded output, that means the system is stable. Okay. Yes. So now, if in terms of the for the system, right, discrete or digital system, if you are talking about this, what are the stability conditions? So we'll write over here stability conditions. And see, very much clear from the diagram which we had drawn, right? This line is giving you a unit circle, and this line is giving you this thing. We know that this area LHP is giving you stable system. That means for your digital system also, if all poles are inside this circle, unit circle, system is stable. Otherwise it is going to be unstable. That means if I just want to draw a small diagram, instead of writing theoretically, if we'll be able to represent it by a diagram, it becomes more appealing. Oh, wait. Okay, see now, if this is the unit circle, I am talking about z plane, means I should write it over here, real z. I'll just change the ink. Otherwise, yeah, this is a real z axis and this is imaginary z axis. Z axis means the imaginary part of your z. So this is actually z plane. I am talking about z plane over here. Again the same thing, real and imaginary. I think no need to write that thing now. Okay, so see, so what I was telling, and minus infinity is giving you this point. That means inside the circle, whatever area is there, right? This whole thing inside the circle, right? If this is I'll write this thing. This is a unit circle. Circle with radius to be equal to 1. Okay, so inside the circle, if all the poles of your system are there, system is stable. So I'll write it, stable region, right? And outside the thing, outside this circle, that means going towards infinity, and here also towards infinity, this is unstable region. Right, so system is stable if all the poles of its transfer function lie inside the unit circle. So one point I'll write, stable if, see, you are going to have transfer function for your in S domain. We had seen, right, poles and zeros, everything is same, because we had seen that. Yes, differential equation also over there, difference equation we got. It is going to have numerator, denominator, definitely again factors will be there, and poles and zeros and everything. Stability part is same there. Then if all poles inside unit circle, right, system is stable, marginally stable. When poles are on the unit circle. And third thing is unstable when poles are out of unit circle. Out of, or I'll write outside the unit circle. Okay, right? So this is all about stability. Now one more concept comes whenever we are talking about stability, and that is region of convergence. So what is that region of convergence? Will talk about, right? And that will be the last topic for this digital control system. Yeah. So now I don't know, I don't remember the point number now. I think it is third one. Yeah, today's third point is ROC, that is region of convergence. That is normally known as ROC. What do you mean by ROC is the value of the function that you are having, right? It should not go towards infinity. It should converge towards some value of the system. Okay, if it is going towards infinity, yes, then the I mean, the region of convergence will not be that particular condition for which it is going towards infinity. Means what? I'll take one example and I'll try to explain. So let me draw one sequence. Let me write first one sequence. Number one, first condition, when you are having your xz is equal to z raised to 1, right? 2z square plus 3z cube plus 4z raised to 4 plus 3z raised to 5 plus 2z raised to 6, plus 1z raised to 7. This is the sequence. This is the xz which is given. Now see, all powers of z are positive, and you know that when the sequence is shifted on the left hand side, then power become negative. When the sequence is going on this side, then the power become positive, right? Because this is lagging, this is leading. So I'll try to draw the sequence over here. So let us see, this is xk axis and this is k, the samples that you are having, right? So yeah, on the axis 0, -1, -2, 3, 4, 5, 6 and 7. Okay, this is the sequence. And if you are writing, see, z raised to 1, that means first instance on the right hand side, magnitude is 1 for that. 1. For this it is 2. For this it is 3, 4. Then for 5 it is 3. And 1. Right? So this is the actual sequence which you are having. Now, if you are talking about this sequence, right, very much clear over here. If you are having z equal to infinity, value of z is equal to infinite, then what is going to happen? When z will be equal to infinity, infinity raised to something, right, and the this function will not exist because your xn will tend to infinity in this case, right? So we'll write function exist, this function xz, this function xz, this function exist except at z is equal to infinity. For all other values, definitely it will be it will have some particular value. So now region of convergence क्या हुआ? ROC will be excluding z is equal to infinity. Okay, the same sequence now if I'll shift, right, I'll try to shift this sequence and this -4th instant 4, if I'll try to bring it on this, we are just trying to see what will be ROC over here, right? Nothing else. Our interest is not anything else. So yeah, let me draw it first again. So now if you are shifting it, right, and you have shifted it by 3 instances, so at this instance you are having 4, correct, and this thing you have shifted it over here, so on both the sides you will have, that means 3, 2, 1, and on this side also 3, 2, and 1. Okay, so 0, 1, 2, 3, and -1, -2, minus the rest of the things are same. This is k, this is xk. Correct. Now if I want to write the sequence, now what is going to happen? See, I'll write it over here. Yeah. Now your xz is, see, 3. That means plus 3. Matlab z cube plus 2 z square plus 3 z plus 4 z raised to 0, right, plus 3 z raised to 1, -1, plus I'll write down over here, plus 2 z raised to -2 and plus 1 z raised to -3. So am I right? 1, 2, 3, 4, 3, 2, 1. Yeah, it's correct. And 3, 2, 1, 0, -1, -2, -3. Correct. Now what is going to happen? If you will have value of z to be infinite, right? Here, if it will be infinity, then also your sequence is going to become infinite. Even if it is 0, so 1 upon 0, again it is going to become infinite. So this particular function, right, it is xz, I'll write x6 except at z is equal to 0 and z equal to infinity. Correct? So ROC will be excluding z equal to 0 and z equal to infinity. Clear? Right? Now again we'll go for the next thing, that is whole thing is in the first quadrant, that is on the left hand side. Okay, so 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so now it is going to be, again this is k, this is x of k, and what will be the sequence now? Sequence will be xz is equal to 1 z raised to -1, 2 z raised to -2, 3 z raised to -3, 4 z raised to -4, 3 z raised to -5 plus 2 z raised to -6 plus 1 z raised to -7. Now very much clear. As soon as your z is 0, right, will become infinite. So I can write xz exist except and z is equal to 0. So here infinity, here both the conditions is 0. So ROC will be excluding z equal to 0. Function will converge for rest all values, but definitely for this value it is not going to converge. Okay, so this tells you the region of convergence. I'll take one more example of region of convergence, so it will be easy for you to understand. So let me save this. Yeah, yes. We'll take example of unit step function, and we had seen it. Unit step signal or function. So unit step function means what? Magnitude is 1, right? For all instances, all instantaneous values are 1. So if you say, yeah, for this it is 1, for this it is 1, for this it is 1, right? And will continue till infinity. So yeah, right? This is k, and we used to represent it by uk, u of k. Correct? Now, if you can recollect, we already solved this thing, and in this case xz is going to be, say what it was, z raised to minus k. It was summation k equal to 0 to infinity uk z raised to minus k, and this is going to be equal to 1. So first term k equal to 0, that is 1 minus the common ratio z raised to minus 1. So this was the z transform of it, right? Even if we'll substitute over here, first term will be k equal to 0, that is 1, right? Plus z raised to minus 1, z raised to minus 2, z raised to minus 3, right? And we'll continue. So this will be the output of this, and we try to represent it as geometric series, if you can recollect, and it was coming out to be 1 upon 1 minus common ratio z raised to minus 1, where this z raised to minus 1 amplitude of this should be less than 1. Or we can write this thing as z is equal to z upon z minus 1, where this z should be greater than 1. Both the things are same, correct? Now we'll try to see the convergence, right? See, if we are writing z is greater than 1, that means definitely at z is greater than 1 we are going to get infinite value. Rest of the values definitely we are not going to get to be stable. So we'll try to see that, right? So if we are saying z is I'll write, if we are saying z is greater than 1, that is z is equal to 2. Let us say example, correct? And I'll try to put that thing in the original series. So you will have xz is equal to 1 plus 2 raised to minus 1, 2 raised to minus 2, and will continue. So I can write this 1, 2 raised to minus 1 means half, 0.5, right? Plus 2 raised to minus 2 means 4, that is 0.25, and will continue. And definitely if we try to get the value 2 upon 2 minus 1, that is 2 upon 1, that is equal to 2. So definitely it is converges. Correct? But you take now z is less than 1, that is, let us say z is 0.5. Now what is going to happen for the series? Right, 0.5, that means 1 upon 2. Okay, so I'll write 1 upon 2 raised to minus 1. 0.5 raised to minus 1, 1 upon 2 raised to minus 2, and will continue. So what it is giving us? 1, right, plus 2 plus 4, right, and definitely this will keep on going and will tend to infinity, and that's why it is not convergent. So if I want to draw the what we can say, ROC area for this particular function, then it is going to be equal to, just a minute. Yeah. Yes. So see now, uh, when z is greater than 1, your system is convergent. That means the ROC for this particular system is this. That means outside the unit circle. My intention to tell you that this thing is that outside the unit circle you will find, yes, the region of convergence is there. When z is greater than 1, the system is stable. So the ROC for this particular system is outside the unit circle, real z and imaginary z. See, not necessary ROC. I mean, what is the connection? No, what is the connection between ROC and stability of the system? We had seen one thing: if the poles are lying inside the unit circle, then the system is stable. And for that, one line I would like to add: for stable systems, ROC always encloses the circle of unit radius. Correct? Because if we had seen that it should be inside, right, all the poles. If ROC is not there, yes, then your system is unstable, because the output is going, I mean the value of that particular function or signal, whatever you are having, it is more than that, and going out of the unit circle, and then the system becomes unstable. So that's why the last statement related to stability is important. Let me save this, and I think I have tried to tell you everything whatever is possible for you to understand, because actually DCS is a whole subject. Taking it in 4, 5, 6 lectures is very difficult. I tried to include, and the main intention is related to the exams, right? Chalo, all the best to everyone. I'll stop sharing.